How do machines learn? How does a machine decide the best course of action in a given situation? These questions lie at the heart of an intriguing field of study known as reinforcement learning. Reinforcement learning, often abbreviated as RL, is a type of machine learning where an agent learns to make decisions by interacting with an environment. This is a stark contrast to the more traditional paradigms of supervised and unsupervised learning, where models learn from pre-existing data. In reinforcement learning, the agent learns through a process of trial and error, guided by feedback from the environment. This feedback comes in the form of rewards or penalties, encouraging the agent to develop a strategy or policy that maximizes the cumulative reward over time. In reinforcement learning, there are several key aspects to understand. First, we have the agent, the learner, or decision maker. Then there's the environment, which is everything the agent interacts with. The agent can choose from a set of actions, which are all possible moves they can make. The current situation returned by the environment is called the state, and the immediate return sent back from the environment to assess the last action is the reward. The strategy that the agent employs to determine next actions based on the current state is called the policy. Finally, there's the value function, a prediction of future rewards used to evaluate which states are beneficial in the long run. Reinforcement learning is particularly suited for scenarios where the right actions are not known beforehand, or the outcomes are uncertain. It's widely used in areas such as robotics, gaming, healthcare, finance, and autonomous vehicles, where the system must make a sequence of decisions that lead to a significant goal. But how does reinforcement learning differ from supervised and unsupervised learning? Supervised learning is a paradigm where a model learns from a labeled dataset, making predictions based on input-output pairs. It's defined by its use of explicit labels to guide the learning process. The main goal is to map inputs to outputs, minimizing the difference between predicted and actual outputs. It excels in classification and regression tasks. Unsupervised learning, on the other hand, involves learning patterns from unlabeled data. Without explicit instructions on what patterns to find, the model must identify the structure and distributions within the data on its own. Unsupervised learning is useful for clustering, dimensionality reduction, and association tasks. So what sets reinforcement learning apart from these traditional paradigms? Well, reinforcement learning operates through a feedback loop where actions influence future data received. This is unlike in supervised learning, where the feedback is static and does not depend on the model's actions, and unsupervised learning where there's no explicit feedback on actions. In reinforcement learning, the objective is to learn a policy to maximize rewards over time, which is different from supervised learning's goal of predicting labels or unsupervised learning's goal of discovering hidden patterns. Moreover, while supervised learning requires labeled data and unsupervised learning uses unlabeled data, reinforcement learning does not require traditional datasets, but learns from the outcomes of its actions in an environment. Finally, reinforcement learning can handle complex environments with long-term objectives, whereas supervised and unsupervised learning are typically applied to more static tasks with immediate outcomes or pattern recognition. In essence, reinforcement learning differs fundamentally in its approach by focusing on learning how to act based on the results of past actions, rather than learning from a fixed set of data. This makes reinforcement learning uniquely suited for problems where the decision-making sequence is crucial. So, the next time you're wondering about how machines learn, remember that there's more than one way to teach a machine. And sometimes, the best way to learn is to try, fail, and then try again.